Today we're on page 3 of our second chapter 9 notes packet, section 9.8, reference angles. We'll actually be covering pages 3, 4, and the top of page 5. This lesson introduces the concept of reference angles and how to find the reference angle to a given angle. Reference angles associated with every angle drawn in standard position except quadrantal angles. There is another angle called the reference angle. The reference angle is the acute angle. It's always an acute angle formed by the terminal side of the given angle and the x-axis. Reference angles may appear in all 4 quadrants. Angles in quadrant 1 are their own reference angles. Okay, here you have a diagram of a 60-degree angle. It's in quadrant 1. It's its own reference angle. It's already an acute angle. Next, if we have our next diagram has a 120-degree angle drawn, right, which ends up, the terminal side is this side right here. That's the terminal side. The positive portion of the x-axis was the initial side, but we focus on the terminal side. And the negative portion of the x-axis, in this case, will form our reference angle of 60 degrees. How do we get this reference angle of 60 degrees in quadrant 2? We simply take 180, the straight angle, subtract our original angle of 120. 180 minus 120 is 60. Next diagram, we have an angle of 240 degrees drawn. So this here is the terminal side, the ending side of that angle. And we always want to go back to the x-axis. In this case, the negative portion of the x-axis again, this forms our reference angle of 60 degrees. How do we get the 60-degree angle measure? We take the original 240 and subtract 180, and that leaves us with 60. And then next we have in our fourth diagram, we have an angle measure of 315 degrees drawn. All right. This is its terminal side, and its reference angle is formed with the terminal side and, in this case, the positive portion of the x-axis. And how much is this angle? We can get it by taking 360 and subtracting the original angle, 315. And that'll leave us with 45. Okay, so the reference angle is measured from the terminal side of the original angle to the x-axis. You never go to the y-axis. It's always the x-axis. All right. If you're in quadrant 2 or 3, you go to the negative portion of your x-axis. So the angle, your reference angle, is formed with the terminal side and the negative portion of your x-axis. Terminal side, negative portion of x-axis. And if you're in quadrant 4, all right, the angle's formed with the terminal side and the positive portion of your x-axis. And if you're in quadrant 1, well, that angle is its own reference angle. Okay, so to calculate the reference angle for angles between 90 and 360, greater than 90 but less than 360, if your original angle is in quadrant 2, the reference angle is going to be 180 minus your original angle. If your original angle is in quadrant 3, it's going to be your original angle subtract 180. Or if you're in quadrant 4, it's 360 minus your original angle. All right. If theta is not between 0 and 360, then you first find a coterminal angle between 0 and 360. And remember, how do you find coterminal angles? You plus or minus 360 degrees. Okay, so find the reference angle for 160 degrees. Well, 160 degree would be in quadrant 2. So for quadrant 2, we would take 180 and subtract 160. So our reference angle is 20 degrees. Oftentimes I'd like to draw this. I like to see a picture of it. So if I draw a 160 degree angle, there we go. There's my 160. Okay, now the reference angle is going to be with that terminal side and this part of my x-axis. And I can also say to myself, oh, well, 160 plus how much more will bring me to the 180? Well, 160 plus 20 more. So there's my reference angle, 20 degrees. How about an angle of 255 degrees? Well, 255, if I think about drawing it, that's going to be 180 plus how much more? Well, it's going to put us in quadrant 3. So for quadrant 3, an angle in quadrant 3, it's our angle of 250, or sorry, in this case 255 minus 180. 255 minus 180 is 75. So my reference angle here is with the terminal side and the negative portion of my x-axis. So that's 180 plus the 75 more. So there's my reference angle of 75 degrees. Again, reference angles are always acute angles. They always have to be less than 90. Next, 301. Well, a 301 degree angle would end up in what quadrant? Quadrant 4. So for an angle in quadrant 4, you get its reference angle by taking 360, subtracting the angle. So 360 subtract 301 is 59. And again, if I wanted to draw it, here's my 301, and then the reference angle would be with that terminal side and the positive portion of the x-axis, and that would be 59 degree reference angle. Now, negative 45 degrees, okay, well, we would get a coterminal angle by adding 360, and that would bring us to 315 degrees. 315 is in quadrant 4, so we'll take 360 minus 315 and get our coterminal angle, our reference angle of 45 degrees. Did you have to do all that? No. Some of you could simply draw a negative 45 degree angle, right? Negative 45, right? But it's going to be its own reference angle here of 45. Next, 580 degrees. Definitely get a coterminal angle first. Subtract 360, and that's 220. A 220 degree angle ends up with its terminal side in quadrant 3. So we would take 220 and subtract 180, and that would result in a reference angle of 40 degrees. Negative 111. Again, that's not between 0 and 360, so add 360 to get a coterminal angle of 249. A 249 degree angle would end up in quadrant 3, and in quadrant 3 we would take the angle 249 and subtract 180 to get the reference angle of 69. Negative 245 degree angle, add your 360 to get a coterminal angle value of 115. 115 degree angle would end up in quadrant 2. And for quadrant 2, we would take 180 minus our angle to get a reference angle of 65. Again, just plugging in to the 3 above. Negative 700 degrees. All right, I'm going to add 360 twice, because I know if I add one 360, I'll still end up with a negative. So I'm going to add 360 twice. That's adding 720 to negative 700. That would leave us with 20 degrees. 20 degrees is in quadrant 1, so it's its own reference angle. Next, when the terminal side of theta moves theta into quadrants 2, 3, or 4, finding the trig values of theta becomes more of a challenge. When our angle moves out of the first quadrant, we must be aware of the sign, S-I-G-N, of a function. We want to express each function value in terms of a function value of a positive acute angle. In other words, the reference angle. Remember, function meaning sine, cosine, or tangent. Right? No, a function is sine, cosine, or tangent. They're functions. These are the steps. We're going to determine the quadrant and calculate the reference angle. Use all students take chemistry to see if the result is positive or negative. Write plus or minus the given function with the reference angle. Okay, so here we go. The sine of 230 degrees. This is going to equal the sine of what? Well, we need the reference angle. So 230 degree angle would end up in quadrant 3. Again, oftentimes I like to draw a picture of it. 230 degrees would end up here. What's the reference angle? It's going to be 230 minus 180, which is 50. Okay, so this would be my reference angle of 50 degrees right here. Using all students take chemistry, all right, our function is sine. Is sine positive or negative in quadrant 3? Well, sine is negative in quadrant 3. So the sine of 230 is going to equal negative sine of our reference angle. So negative sine of 50 degrees. That's our answer. Number 2, cosine of 305 degrees. Well, a 305 degree angle would end up in quadrant 4. So this is going to equal, I can just, is cosine positive or negative in quadrant 4? It's positive, so it's going to equal positive cosine of the reference angle. What is the reference angle for 305? It is 360 minus 305, which is 55 degrees. Excuse me. So the cosine of 305 degrees is equivalent to positive cosine of 55 degrees. Next, tangent of 110 degrees is going to equal, is it going to be positive or negative tangent of the reference angle? All right, and the function here is always going to stay the same. 110 degree angle would end up in quadrant 2. Would have a reference angle of 110 plus 70 more, or 180 minus 110 equals 70. In quadrant 2, is the function tangent positive or negative? It's negative, so it equals negative tangent 70. Next, the sine of negative 190. Well, you can either get a coterminal angle or you can draw a negative 190. I think I'll do both. If I draw negative 190, that's negative 180, and then how much more? 10 more. All right, so my reference angle would be 10. What quadrant does my angle terminate in? It terminates in quadrant 2. Okay, so this would equal Again, the trig function would be the same, sine. Is it positive or negative? Is sine positive or negative in quadrant 2? It's positive. And the reference angle was 10, so it would be equivalent to positive sine of 10 degrees. Now, if I didn't draw the negative 190, but instead, let's say I added the 360 to negative 190, and that would have brought us to 170. 170, I want to correct that. All right. And then we would draw a 170 degree angle, get our reference angle by taking 180 minus 170 is 10. Next, the cosine of negative 250. All right, I'll do this one where I'll add and get the coterminal angle. Coterminal angle is 110. 110 degree angle would end up in quadrant 2. In quadrant 2, is the function cosine positive or negative? It's negative, so this is going to equal negative cosine of the reference angle. In quadrant 2, the reference angle is 180 minus 110, which is 70. And number 6, the tangent of 200, a 200 degree angle, would put us in quadrant 3, where tangent is positive in quadrant 3. What's the reference angle for this 200 degree angle? 180 plus 20 more. So the reference angle is 20. So tangent of 200 would equal positive tangent of 20. The other way of getting the reference angle would be 200 minus 180, which is 20. Okay, next, finding exact values of trig functions. Again, whenever you see exact values, then you're going back to your special right triangles. Okay? Use 30, 60, 90 or 45, 45, 90 triangles to get exact values of sine, cosine, and tangent. To find the exact value of the cosine of 135 degrees. We already have a 135 degree angle drawn for us here. And the terminal side is this. And we find the reference angle, which happens to be done for us already. All right. So the cosine of 135 degrees is going to equal, we are in quadrant 2, where cosine is negative, so it equals negative cosine of our reference angle, 45 degrees. Let me just write down some steps here. First step we're going to do, we're going to draw the angle, make note of the quadrant, of what quadrant the angle lies in, and the sign, meaning S-I-G-N, sign. Next, you get the reference angle. Then we're going to write the function, as a function, value of an acute angle. Write as a function value of an acute angle and evaluate. So, draw the angle, note the quadrant and its sign, get a reference angle, write as a function value of an acute angle, and evaluate. Okay, so now, so we're here, we had the function value of negative cosine of 45 degrees. Now, what's the cosine of 45 degrees? If you need to, draw your special right triangle. Legs are 1. Hypotenuse is square root of 2. Cosine of 45 is going to be 1 over the square root of 2. 1 over the square root of 2. Bring down my sign, my SIGN, right, was negative, so negative 1 over square root of 2, where if we rationalize the denominator by multiplying by 1 in the form of square root of 2 over square root of 2, our end result is negative square root of 2 over 2. There we have our exact value of the cosine of 135 degrees. Okay, and if you can bear with me for one more. Find the exact value of cosecant of 300 degrees. Right, remember, step 1, quadrant and sine. Well, we'll draw the angle. So 300 degrees puts us in quadrant 4. So we're in quadrant 4, where cosecant, right, that's the reciprocal of sine, right? We're thinking cosecant is a reciprocal of sine, and sine, is it positive or negative in quadrant 4? All students take chemistry. It's negative in quadrant 4. So cosecant is negative. Next, we get the reference angle. What's the reference angle? All right, well, in quadrant 4, to get the reference angle, that's going to be 360 minus our 300, which is 60. And again, I always like to have a picture, so here I am. Here's my 60-degree reference angle. Okay, so cosecant of 300 is going to equal negative cosecant of 60 degrees. So we've written it as function value of an acute angle. And now, for a 30, 60, 90 degree right triangle, opposite the 30 is 1, hypotenuse 2, opposite the 60 is square root of 3. Cosecant, remember, is the reciprocal of sine. So sine is opposite over hypotenuse, so we want hypotenuse over opposite. In relation to our 60-degree angle, hypotenuse is 2, opposite is square root of 3. So this is going to equal negative 2 over the square root of 3. Again, rationalizing the denominator, it's equivalent to negative 2 square root of 3 over 3. All right. Thank you for hanging in there and staying with me for this video.